In this video, I will show you how to implement Angular application authorization based on JSON Web Token, abbreviated as JWT. You will learn how to restrict access to the given parts of your application with router guards so that only authorized users would be able to access them. Also, you will see how to intercept HTTP calls adding access token required by server. Finally, you will learn why we need refresh token and how to use it transparently for the user so that he is unaware of access token expiry and following refreshing process. This is Angular Academy. If you are new here, don't forget to join Slack channel to discuss the topic of this video using the link in the description. Also, if you want to be on top of future lessons, click subscribe. Our application for this tutorial is composed of two routes. First route is available under login URL, as you can see right now. This is our login component. The second route is available after login under secret random number URL, and the component under this route presents random number generated by the server. If I manually try to access protected URL, I will be redirected back to login page. So let's try to log in and analyze the application further. We managed to log into the application and a couple of things happened. First of all, note that we can access previously unavailable route. Secondly, we can see some API calls. Let's take a look at them. We can see that the request to random API endpoint has authorization header with some string. This is our JWT token. It was generated by the server when we were logging in with the credentials. And you can see the result of that query here, JWT and the refresh token. Later, I will show you my backend server implementation in Node.js with Express and Passport. For now, let's focus on Angular part. Finally, let's take a look at local storage for this website. The application stored both tokens, and they are going to be used when we refresh the page. So let's try to do this. As you see, I totally refreshed the page, and those values, because they were persisted in the local storage, were used again, providing our access to protected route again. Now, let's take a look how we can implement such application. Our root components template app component HTML contains router outlet, so it will present routed component here. App routing module is the place where the root routing configuration is implemented. We can see two routes here. The first is previously mentioned login route with login component. Additionally, we can see it has auth defined inside can activate array. This is the router guard that tells the Angular router if it's allowed to activate given route. Let's take a look at that guard. This type of guard implements can activate interface, forcing it to implement can activate method. In our case, we make use of auth service that answers the question if the user is logged in. If that's true, we would like to redirect the user to our secret page, as there is no need to log in. Finally, we need to give an answer to the router if the route can be activated. Again, in our case, we would like to say yes only if the user is not logged in. This is the moment to take a closer look at auth service. Auth service has a bunch of important methods implemented. Let's analyze them one by one. First, we have login method. This is HTTP post call to a backend API with user credentials. Since we receive a observable, we would like to use pipe again to apply some RxJS operators. First is tap, which would actually take the values from the stream and apply some side effects. In our case, it's doLoginUser method. Later, once we consider it successful, we would like to map the value to true. And in case of error, we would like to display alert to the user and return observable of false, because we would need to somehow provide the result of this method to a code which would be calling this login method and inform about either success or failure of this operation. So what does doLoginUser method do? doLoginUser would take the username and tokens and just store the username and call storeTokens. StoreTokens method would take our tokens and save them to local storage under defined keys. So this is how we do login. Let's see how we can implement logout method. The same as previously, we are doing HTTP post call to different this time API endpoint logout. Inside of the body, we would like to pass over refresh token so that the server would know which refresh token to remove, and then it would not work anymore. Then we are using pipe again to use tap operator to execute doLogoutUser, and again map the result of this whole method to true so that the client of this method would know that the operation succeeded, and in case of error we would like to display an alert and map the value to observable of false. What does doLogoutUser do? doLogoutUser would remove logged user name from the component and execute remove tokens. As you may presume, remove tokens would remove access tokens from the local storage. So for now we have learned how to log in and log out, but Auth service has also one very important method, refresh token. I will explain the concept of refreshing later in this video, but for now just note that it executes HTTP post to refresh API endpoint with refresh token in request body and expects tokens object to store JSON Web Token in local storage. So we have our tokens stored in local storage and we want to authorize outgoing HTTP calls with JWT token. Of course, we can manually add authorization header to outgoing HTTP calls in service methods, but this would cause a lot of duplication. Instead, we can make use of HTTP interceptor. Here you can see token interceptor, which is Angular provider that implements HTTP interceptor and intercept method. If we properly register this provider, what I will show in a second, this method would be used to intercept, or in other words process, every outgoing request executed by HTTP client. What we want to do here is to check if JWT token is available and attach this token to outgoing request so that it will be authorized. Let's examine add token method. What this method does is takes request and set authorization header with the value bearer token. So exactly what we saw at the beginning of this video. Next part of intercept method takes care of error handling and refreshing in case of 401 HTTP error, which is unauthorized error code. But before we do this and analyze this part, let's look how to properly register our token interceptor. To do this, we need auth module and providers array in module metadata. And as you can see, I have HTTP interceptors, provider, and I use class for my token interceptor. And I also say multi-true, which basically says that this is multi-provider, which means that we can have multiple HTTP interceptors. We already know how to write authorization service and make use of router guards. We also know how to use HTTP interceptors to add tokens to our requests. Now it's time to explain refreshing process, but before we do that, let's first understand how JSON Web Tokens actually work. JWT tokens are self-contained tokens that securely represent claims, for example, the fact that the user has an admin role, between parties. In our case, those parties are client and server. That's why we attach tokens to authorize requests to the server. Self-contained means that the server does not store tokens anywhere. It just decodes the information inside of them. We can use JWT.io website to decode JSON Web Tokens manually. Let me paste our JWT here. So we see three sections: header, payload, and signature. The header contains the algorithm used to generate the token and the type of the token. Payload, in our case, contains username, role, issuing timestamp, and expiry timestamp, after which token is considered not valid anymore. Signature is used to verify if the token has not been modified after being securely signed by the server with special secret key that should be known only to the server. If we modify the token, we can see that the signature is considered invalid, which means we should not trust this token anymore. The self-contained nature of JWT has both advantages and disadvantages. On one side, it brings scalability to the system because no matter which server of our backend cluster the query hits, there is no need to ask any persistence layer, for example database, to verify the token. But on the other hand, there is no way to invalidate the token in case it gets into possession of improper person. To alleviate this risk, JWT should be short-lived. The exact time that the token should be valid depends on the system requirements. So now you may ask a question: what would happen when the token becomes invalid, let's say after 5 minutes? Does it force the user to provide his credentials to log in again? Let's see how our demo application will behave if we manually change the value of JSON Web Token stored in the local storage. So here we have our JWT token, and let me just randomly change its value. Now I'm going to refresh the application page, and as you see, we still have an access to secret random number. To understand what happened here, let's look at the requests list. First, we received unauthorized response from the server when the value of the token was 123. Obviously not valid token. So the application attempted to refresh the token, as you see with this API call. It passed refresh token in request payload, and as a result we received new JSON Web Token that was again issued for the given period of time. And after that, the query to random API endpoint for the value of random number succeeded. So how to implement this in our application? When we changed the value of the token, we made the server to respond with error code 401, which is HTTP's unauthorized response code. This caused interceptor's error handling logic to execute. If the response code of that error is 401, we can make an attempt to refresh the token with handle 401 error method. Let's take a look what this method does. This method is divided into two branches. First one for executing token refreshing, and the second for blocking and releasing all the other queries that started during the refreshing process, which we want to put on hold until we have new JWT token. Let's analyze the first part. We enter this branch if the value of isRefreshing flag is false. This means that refreshing has not yet started. Once we enter this section, we set isRefreshing to true, indicating that the refreshing has just started. Next, we use behavior subject, refresh token subject, and populate the next value of null. This will block another requests in the second part. I will explain it in just a second. Here, we are calling refresh token to obtain new JWT token, and once we have it, we can indicate bug that refreshing has finished, setting the flag to false, and populate the new token through behavior subject and continue with the request that initialized the whole method. But what happens when during the refreshing, so after requesting the new token and before receiving it back, there are some another queries and our interceptor processes them? There is the second part which comes into play now. Do you remember when we used refresh token subject? During the moment when the refreshing is happening, the value inside of this subject is null. And this filter would block all the requests until the value in that subject is different than null, which actually would happen when we get the new token here. After that, we use operator take one to transform it to observable, which will finish after taking one event from that subject, and then we want to release that query that initialized this logic here, which means it will only happen once our token is received back during the refreshing process. So far we have learned how to use router guards, how to implement HTTP interceptors, and how to do token refreshing. In the last part of this video, I would like to show you how you can use Passport.js in your Node.js backend implementation to secure API endpoints with JWT. Here I have very simple Express.js server implementation with a couple of settings and middlewares used. Here you can see the configuration of middleware JWT strategy from Passport.js library to check and validate the token based on expiration date. Now let's take a look how do we do login, logout, and token refreshing in this Node.js application. Here we have a login endpoint. We take username and password from the request body, but for the sake of this example, we don't make any use of password. We just take a username to construct user object. Again, for the sake of this example, we just give this user admin role. We use JWT implementation to sign the token with user payload and with the secret, that is this secret password that has to be known only to the server, which later is used to verify this token. And we also set the time in which this token expires. This is 10 minutes, 600 seconds. Then we generate a refresh token, which is random string, and we store this refresh token in an array with the value of this username, which would means that this refresh token belongs to this user, to the user with this username, and we reply back to the client. Let's see now how we can do logout. So here we would just take refresh token from request body and delete it from the array containing refresh tokens. Note that in some production ready implementation, those refresh tokens may be stored in some persistence layer like database or somewhere else, not in memory as in that example. Finally, let's take a look how refresh method under refresh URL endpoint looks like. We will take again refresh token from request body, and if this refresh token is in our array, we would take the username under this property inside of refresh tokens array, creating new user object for the payload for the new JSON Web Token, sign it, give its expiration time, and send it back to the user or to the client. If the refresh token is not inside of known refresh tokens, we would send 401 unauthorized HTTP code. Finally, our random endpoint that generates random value is secured with passport authenticate method with JWT strategy. So that's it for today. If this video helped you in any way, please click like button, and if you want to stay on top of upcoming lessons, click subscribe. See you next week.